The scientific method is a series of steps used to study the natural world. It's the model that has been proven to be the most effective and reliable way to discover and study scientific and social information. Throughout human history, there have been many forms of the scientific method, ranging from only 3 steps to 4, 6, 10, or 12, but they all follow the same basic ideas of observing, making a hypothesis, testing, and concluding.
Hi there. Today we are going to be talking about forces. Just to clarify, we are not going to be talking about the Force from Star Wars, even though that's pretty cool. We'll save that for another time. Anyways, let's define force. When people talk about force, you can think of it as a push or a pull on an object. For example, imagine a baseball bat hitting a ball. You are applying a force to a baseball when you hit it with a bat.
So first, let's go over what a phase change is, and it is when one state of matter changes into another state of matter. So solid to gas, liquid to gas, gas to liquid.
There are many ways in which Isaac Newton's first law of motion can be applied to everyday situations in the natural world. One example is that a runner in a race will continue moving even after they have crossed the finish line because their body is resisting change in its motion. Another example is that a hockey puck is moving along ice, which is a surface with a lot less friction, and you have a hockey puck that is moving along concrete. Concrete creates a greater friction force than ice. Therefore, the hockey puck on ice will maintain its velocity longer than the hockey puck on concrete. The external force is the friction acting against the puck, causing changes in its motion. It will eventually stop because of this force.
First, let us assess what Emma's current energy demands are in a typical day. Using the chart provided in the textbook 12.4, we can measure Emma's caloric needs with the following equation. We recorded the activity Emma did and for how long. Activities included sleeping for 12 hours, Zooming for 2 hours, TikTok for 4 hours, school for 4 hours, and work for 2 hours. Then we multiplied the estimated number of kilocalories per hour for that particular activity, according to table 12.4 in the textbook, with the amount of time in hours the activity was performed. As the answer, we found that delta U equals negative 2,594, which means that Emma uses on average 2,594 kilocalories per day when only doing activities like the ones listed. To avoid slowing her metabolism by eating less often, Emma decided to lose weight by ramping up her workout routine and keeping her diet the same. Because Emma's car is having some technical issues, she now has to walk instead of driving to school. When driving, she expends 144 kilocalories per hour. Now, when walking, she expends 360 kilocalories per hour, a difference of 216 kilocalories per hour, or running when she is late. Emma added an hour per day of running, 990 kilocalories, and increased her work hours at the grocery store from 2 hours a day to 5 hours per day, which gave her less time to idle on social media. So Emma's new daily metabolic rate looked like this. We recorded Emma's new daily activities and how long she did them for. These activities included sleep for 12 hours, school for 4 hours, work for 5 hours, running for 1 hour, walking to and from school combined is 1 hour, and being home doing light activity for 1 hour. Then we multiplied the estimated number of kilocalories per hour for that particular activity, according to table 12.4 in the textbook, with the amount of time in hours the activity was performed. As an answer, we found that delta U equals negative 4,059. This means that Emma uses on average around 4,059 kilocalories per day when only doing activities similar to the ones listed. This new routine creates a difference of 1,465 kilocalories from Emma's previous lifestyle. This extreme increase in caloric expenditure enabled Emma to lose her 5 pounds in just 12 days, not recommended for long term.
As Ibn al-Haytham once said, if learning the truth is his goal, is to make himself an enemy of all that he reads. Meaning, it's important for researchers to question what they read. Look at the methods and materials used. See what the sample size was. Read the entire report, not just the title and abstract. An essential part of this scientific method is verifying past findings so that you can accurately expand on human knowledge.